Hello and welcome to Home Science Lessons of Mr. Mac. Lesson 5, Series and Parallel Circuits. So remember, put your phones out of the way, get rid of distractions, and have a pen and paper handy and get ready to crack on. Try and do this session all in one go and to the best of your ability. Go for it, you can do it. Okay, so the lesson design, same as always, a bit of retrieval practice, a couple of examples of teacher instruction from me, some opportunities to embed and drill, and then of course opportunities to practice what you've learned and apply the knowledge. Okay, retrieval slide number 1 today is on structures and bonding 1. You may want to pause just at the moment, have a go, and then I'll reveal the answers in a few seconds. Go for it. Okay, here are the answers then. Have a go at marking them. If there's any that you got incorrect, please go back and revise them again. That's really important. Okay, slide number 2 is looking at last lesson's work, all about the different circuit components. So see if you can write down the name of the symbol and then match it up with the correct voltage current graph. Pause the video, go for it now. Okay, and there's our answers. So we've got resistor, lamp, and diode going from left to right, and there's the shape of the graph. And remember we've got our little memory cue to help remember what to do. So resistor, our lamp, which looks like a street lamp, and our curve round the graph for D for diode. Our third and final retrieval slide today. Again, it's about the lesson last time because there's a lot of content there that we needed to learn. So if you could have a go, pause, have a go at writing what is happening in each of the boxes. Okay, thank you for having a go with that. And there are our answers. If you need to pause the video for a moment to write some of that down or to fill in any missing content, absolutely fine. That's what the resource is all about. Okay, last time as well, we had some slot questions which are attached to show my homework as a Word document. And there are the answers. So there were some questions on filament lamps, resistors, and diodes. Okay, now on to today's new knowledge, which is on voltage and current in series and parallel circuits. So we're going to have a look at that. Here we go. Right, so our new knowledge today. What is a series circuit? A series circuit has a single conductive path or loop. For example, if I was to draw one, that would be an example of a series circuit, one loop. Okay, what are the circuit rules for current and voltage in a series circuit? In a series circuit, the current has the same value at any given point. So that means if I was to measure it here, here, or here, I would get the same reading on an ammeter for current. So therefore, what about voltage or potential difference? Okay. The potential difference of the power supply is shared between components. Okay, so that means if I was to have several bulbs there, say if I was to put another bulb in here, the potential difference is shared between the two bulbs. So those are rules for series circuits. So current is the same and all the way around or at any given point, and potential difference is shared between the components. Now, what about a parallel circuit, the other type of circuit that we need to know? So first of all, what is a parallel circuit? In a parallel circuit, electrical components are connected alongside one another, forming extra loops or more than one loop. Okay, so here's a little example. We've got our cell, we've got our bulb here, and then we've got a second loop with our second bulb on it. So what are the circuit rules for current and voltage in a parallel circuit? Let's have a go at that then. In a parallel circuit, the total current is the sum of the current through each loop. Okay, so what that means is the total current is the current going through this loop plus the current going through this loop. So in a parallel circuit, the total current is the sum of the current through each loop. So what about potential difference or voltage then? In a parallel circuit, the potential difference across each loop of the circuit is the same. So if we had, say, for instance, 2 volts across the cell, then it would also be 2 volts across both of the bulbs, and you would not have to share it as you would in a series circuit. So you can see there's some more information here about resistors. We're going to come on to that a little bit later on. So if you could pause the video, make sure that you've got any of the notes written down that we've just been talking through. And you've got time to sit and have a little read over them. So that's our new knowledge that we just embedded. Remember, drill, drill, drill. Drill is thrill. So what does drill, drill, drill mean again? Well, drill, drill, drill means that you get the notes that you've just been looking at, read them, cover them, write down on a blank piece of paper what you can remember, and then go back and check your work. So it's look, cover, write, check. Or if you're lucky enough, you can get someone at home to test you on what you've just been doing. So give the piece of paper over to them and they can ask you a few questions. Okay, so you've noticed probably at the bottom of the page last time that there was a piece of new knowledge that said, what are the circuit rules for resistors in series and parallel? Well, there's an experiment that we would normally do in class. And in that experiment, we would actually investigate the resistance in a series and parallel circuit using resistors. So there's the method, there's the circuit diagram and the method for a series circuit. So we've got an ammeter to measure current, which obviously is going to be the same at any given point around the circuit. And we've also got a voltmeter to measure the voltage or potential difference in the circuit. And we can divide potential difference by current, and that will tell us the overall resistance of the circuit. Second experiment or version of this experiment is putting the resistors in parallel. So we would put the circuit together, as you can see there, with a loop for each resistor. We would use an ammeter to measure current and a voltmeter to measure voltage or potential difference. And then we can divide potential difference by current to find the resistance in that circuit. Okay, so there's some new knowledge that we're going to go and have a look at now under the camera again. And that is the circuit rules for resistance in a series circuit and in a parallel circuit. So that's the next little thing that we're going to have a go at modeling. Right. So what is the rule for resistors in a series circuit? So in a series circuit, the total resistance of two components is the sum of resistance of each component. And we can write that as R total, or total resistance, is equal to resistance of component 1 or resistor 1 plus resistance of component 2 or resistor 2. So we simply just add the resistances together to get the total resistance in a series circuit, because the current needs to go through both resistors or both components. Right, what about a parallel circuit? A little bit different. The total resistance of two resistors in parallel is less than the resistance of the smallest individual resistor. So say we got our circuit, we've got resistor 1, we've got resistor 2. The total resistance there will be less than the resistance of the smallest of these two resistors. You don't need to have to be able to calculate total resistance in a parallel circuit from the resistors themselves. Okay, you may be asked to calculate resistance in different loops, but you won't be asked to calculate total resistance in a parallel circuit, but you may be asked to calculate total resistance in a series circuit, which we spoke about a minute ago, is just adding resistor 1 to resistor 2 to get the total resistance. Okay, so I hope that makes sense. The reason why the resistance is smaller in a parallel circuit is because it's easier for the current to be able to flow, because it can flow through each loop before going back to the power source, whereas in this circuit, it has to flow through both components of resistors before going back to the power source. So again, write your notes, pause the video if you need to, and of course we're going to embed that new knowledge again with more drill, drill, drill. Remember, drill is thrill. So get into that, really get into the habit of, as soon as you've written down the new notes, drilling on that new information until it's really rock solid in your memory. And then of course, later in the week, coming back and having a look at it again, because 3 or 4 times during the week looking at this before you do your recall test is going to be better than just looking at it once, because there'll be more forgetting. If you forget a little bit of it after looking at it the first time, that's fine, because that's when you look at it again, that's further embedding it in your memory. So there's a slot task that is attached to show my homework, slot task 4, and you can print this out if you wish, or you can just write down the answers on pen and paper that you see on the screen, and the answers to that will be revealed next time. Those questions focus mainly on calculating resistance in different circuits. So our next lesson is going to be on thermistors and light-dependent resistors, or LDRs. Until then, drill, 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 and the new stuff you've learned today. Don't forget about the other lessons that you've done this week as well, or the other information that you've learned on electricity. Look out for, complete the slot activities, obviously, as you just said on the last slide. Look out for the recall test on Friday, and see if you can learn the information so well that you get a really good mark at your first attempt at the recall test. Don't forget, tell your buddies all about the videos, and do some really good learning remotely. Again, thank you for working hard. Thank you so much for listening. Thank you in advance for completing those different activities. See you soon. Goodbye.